Hello and welcome to the video series on runtime analysis for AUTOSAR embedded projects. My name is Florian Sommer and I'm responsible for the business development of the product line embedded software at Vector Informatik in Stuttgart. In this video, we're going to talk a little bit more about the comparison between the different classes of real-time analysis that are introduced in the first video. At first, for sampling, let's take here a very simple example that is very commonly used in many different ECU projects. And in this example, what we have done is you are simply toggling a pin every time a task is getting activated and every time the task is not running anymore on the core. So you will see a picture like this where you have where you're simply toggling the pin every time it's active. You can see on the oscilloscope that that you have a high signal and you have a low signal whenever this task is not running on the core. This is a very easy method for sampling, and it's widely used in different projects. For statistics, what you get here is basically the statistic values that are related to the runtime of these tasks. So you can see what was the minimum, maximum, and average runtime of this task at the time of the measurement period. And throughout this measurement period, you will also be able to determine how much was the CPU load of this task. Now let's have a look at the timeline that you get with this class of timing analysis. So you can now see for this task 2 milliseconds, you can now see all the different activation points here shown by these arrows. And you will additionally be able to see whenever this task changed into a preemption state. So it was not actively running on the core, indicated here by the light green color. When we compare now sampling versus timeline, or in particular this approach of toggling a pin with the activation and termination of a task, let's compare that to a complete timeline of the task and also with additional tasks. So this is the results you get when you only have a look at the activation and termination point of your task. If you are measuring the state changes of the task, then you will now be also be able to see that this task actually took, of course, the period of time that you can see from this oscilloscope picture. But what's very interesting and what is highly relevant when you want to solve issues like high CPU load and so on, or if you have delayed responses from certain tasks, you need to see how often this task was preempted. And this is something that we can see very easily in this picture, that the task was preempted for quite a long time. So the actual netto runtime of this task is not really long, but it gets preempted nearly every time when it's activated on this core. If you want to analyze the reason why this task is being preempted in this recording, then you will need to record also additional tasks that are running in the system. And how we do that and how you can analyze the interference between the different tasks inside your system is something you will learn in the next video. At the end of this video, I want to offer you some possibilities to stay in touch and find out more about timing analysis. For that, I'm inviting you to join the LinkedIn group Runtime Analysis in AUTOSAR Projects. In this group, you will meet other people working in this field, sharing their experiences and solutions for this topic. And you will, of course, also be able to engage in discussions and ask your questions there. Just search for the group directly on LinkedIn, or if you want to have it easier, I put a QR code here in the video so you can simply scan the QR code and you will be redirected to this group. Would be happy to have you in the group. If you have questions to me directly, or if you want to connect with me, I'm inviting you to scan the QR code here on the right. You can also see the link to my profile here on LinkedIn. I would be very happy to connect with you and answer any questions you have. Thank you very much for watching this video. I'm looking forward to stay in touch with you.